Okay, so let us
Let us let us
okay, so let us start our discussion of week 8. So good evening everyone and welcome again to our NPTEL live session. So we are having the discussion of week 8 for the course of non-conventional energy resources. The course is taken by Professor Prathap Haridoss from IIT Madras, and I am taking the live interaction session for this course. So again, as my introduction, I am Lalit Bharti, a Prime Minister's Research Fellow in the Department of Physics at IIT Kharagpur. These are my email and LinkedIn profile IDs, so you can contact me over there. And if you have any queries regarding this course or any other relevant queries, you can either mail me there or connect me there. And I'm always happy to help you there. So in today's session, we will be mostly discussing our wind energy, and we will be covering the syllabus of week 8 from the NPTEL main lectures. So in week 8, we'll be discussing the wind energy efficiencies and wind energy, there are parts and type of materials, and what are the properties of material, which kind of materials are preferred, then which type of design are preferred and types of the designs, and all pros and cons of different designs of windmills. So basically today we will be covering the wind energy part. So I will take the assignment questions first, and then if the time permits, we will be having further discussion on these questions. So I'm starting with the questions of the previous year or the relevant assignments, which can be helpful for your exams as well as your uh, any problems you are getting in your main lectures. So our question one, these questions are the uh, non-graded assignment questions, so it may feel easy, but they are necessary to do. So let us start with the first question. It says the blades of windmills experience cyclic loading and hence must have the excellent fatigue properties. So fatigue properties means we need to understand what is the fatigue properties. So fatigue properties means the material should withstand the mechanical cycling. Mechanical cycling means if they are getting a load, let's say you have a metal rod and you are bending it mechanically, so it is facing mechanical mass loading or mechanical loading. So if the rod is withstanding, let's say 1,000 cycles, without cracking or without damaging. So we can say yes, for 1000 cycles the mechanical is excellent, having excellent fatigue properties. So since the windmills blades are facing the high winds, and they are continuously rotating, so while facing the winds, they bends, their corner bends and the material bends, basically they get the mechanical loading. So they need to be excellent in fatigue properties, so there will not be any cracks formed, or they will not bend, or they will not uh, be damaged. So these are the few properties of rotor blades. So basically they are made up of either steel, but steel is heavy in the mass comparatively to other composites of aluminum. So it is also made by aluminum in their composite. So it should be lightweight, and we know that it should be having fatigue resistant properties. The strength should it should be able to load good strength. They should be stiff. Stiff means integrity of shape. So the shape should not change with their loading or any mechanical bending or any kind of damage. The shape should not change. Environment, uh, as well as blades recycling. So these are few parameters which should be considered while choosing the material of rotor blades. Then we'll go to our next question. So it says Betts limit represents the minimum efficiency that a windmill must have to be commercially successful. So let's say what is the Betts limit? So Betts limit is provided here below. So it is the Betts law indicates the maximum power that can be extracted from a windmill independent of their design of a wind turbine in open flow. So basically, whichever kind of windmill we have, whatever is the max possible output, theoretically in idle condition, that is governed by the Betts law, or the Betts law give the maximum possible output values. So this is the maximum possible, not the minimum. But in this question, it is given that minimum efficiency. So that is wrong, and the maximum is correct. So we can say that this statement is false. That not it is not the minimum efficiency. It is the maximum efficiency what we are talking about. So this was the question two. Then we are having our third question. So it is again on the windmills or different types of windmills. So it says in direct type of wind turbines, the tip speed ratio can be greater than 1. So let us uh, see what is the tip speed ratio. So the tip speed ratio or lambda or TSR for the wind turbine is the ratio between the tangential speed of the tip of the blade and the actual speed of the wind. So what does it mean? So tip of the blade versus the wind speed, you can just convert it, or you can say the tip of the tip speed of the blades. Let's say this is your blade and this is your tip of here. So tip speed versus the wind speed. So obviously it is always less than 1, because the tip speed cannot be greater than the wind speed. So this rule is always followed. So it is always 1. So if we have the high lambda values, or the tip speed ratio values near to 1, so that will be called a very good design. And if we have lambda values very less than 1, then the design is not preferred that much. So we want them to be high in TSR values. So we have different type of windmills. First one is lift type and drag type. So what is the main difference? In the lift type, we have the surface area to be low. So you can see the winds are sharp in nature, where in the direct type, our surface area is quite high. You can see the surface area is quite high, or you can see this is whole surface area. So surface area is quite high, and speeds of rotating will be higher for the lift type versus the direct type. But direct types are preferred when they are either for vertical type, or the places where wind speed are very low or relatively low, where there the direct type of the windmills are preferred. So they can be preferred in any household or at a rooftop applications. Otherwise, for commercial or for large size windmills, mainly the horizontal type, the lift type windmills are much more preferred. So our question was, in the direct type of windmills, the tip speed ratio can be greater than 1. So it cannot be greater than 1. We have already seen it should always be less than 1. So the statement is false. Then we go to our next question. So this question is again on the horizontal type or the horizontal axis wind turbines. So the question says, two blades, two blade horizontal axis wind turbine experience uneven forces due to the presence of tower. So this is the example of your two blade design. So this is the blade 1, this is the blade 2. So we have seen that in the design of two blades only, so this tower make a hindrance or uneven forces, generates uneven forces while the rotation of these blades. So because we have enough remaining area, let's say this is your blade area, but we have enough remaining area uh, which will produce you can say the low pressure region. So due to that, your tower will interfere with the two blade design. That is why this two blade design is very rare in horizontal axis windmills. So the most optimum design is the three blade design in case of large scale horizontal axis windmills, because the sweep area of the blade is the optimum for the three blade design, and the hindrance caused by the tower is the minimum in this case. So there is a specific design. So this three blade design is the best for this type of windmills. So the question was, two blade design with wind turbine experience uneven forces due to presence of the tower. So yes, true. It the statement is correct. Then we go to our next question. It says modern windmills use blades made of concrete. So that is clearly incorrect, because we know the concrete is not following our criteria. So we just saw in the first question what should be the criteria for a windmill blade design. So it should be stiff, it should be strong enough, it should be having uh, lightweight properties, and it should be fatigue resistant. So neither of them can be followed by the concrete design. So it's clear that concrete cannot be used in that. So most of the designs are using steel or aluminum composites for their blades. So then we are again these five questions are done from the non-graded assignment. Now we are having the graded questions from previous year. These are more important for your main exams. So by the time, I also request everyone to just write your name and mark your attendance in chat box. So the question is the formula for calculating wind power. So this is, we have already seen this formula in I guess in our previous lectures, or otherwise not. It is mentioned and it is derived in the main lectures, which is available on NPTEL or in the uh, notes provided by them. So we are not going to derive this formula completely, but the main thing here to understand is it is this v1 square minus v2 square. This is the most important, one of the most important term, because it is difference between the air coming from before hitting the windmill and after hitting the windmill. So v1 and v2. So the difference, if the difference is more, so then the power conversion will be more. So means if you have 100% of, let's say, wind speed, so if you are getting 50% only, means your 50% power is absorbed or the converted by the windmill. So your power, your wind power, this is directly proportional to your uh, difference in wind speeds. So this is basically v1 square minus v2 square. Again, this is proportional to A. A is your sweep area or area covered by the windmills blades. So that is also important, because larger the sweep area, more power you can convert from the windmill. Then it is again proportional to your V, sorry, yes, V and rho. Rho is basically the density of fluid, you can say. So that is fixed for here. So main, if you do the derivation, you will get the third as your correct answer. Then we have the question on Bates limit. Bates limit or Bates law we have already seen in last question. So Bates limit is the maximum limit which can be the maximum limit of efficiency which can be achieved by a windmill. So the question says Bates limit is blank maximum efficiency for a wind turbine. According to it, this much percent of the kinetic energy from the wind can be used to spin the turbine to generate electricity. So we know that yes, it is not experimental limit, it is the maximum theoretical limit, and the limit is 59.3%. So this is the highest possible efficiency of a windmill. So the windmill efficiency cannot go above 59.3%, and typically these are in range of 35 to 45%. So this is the Bates law, and it is clear that it is the answer is second, theoretical, and 59.3%. Then we get the next question. It says if v is the velocity of wind, energy available to wind power is proportional to what? So we have already seen in our previous question, but we are again just checking it. So the power is, the formula for power is given by half rho a v cube. So either you uh, v cube. So let us see for the maximum power condition. So what you need to do, you just take the derivative of power, because energy available, we are not asking about the power available. So if the power was asked, it is directly v to the power 3, or from our the relation from the power also, we can directly get this is the v and this is v square, so we will get v cube. But they are asking for, but they are asking for energy. So what is the relation of energy from power? So this is the relation. You can get E, or E is equal to dP by or dt, otherwise just the derivative of P. So this is your P, or P is proportional to V. P is proportional to V cube. So we will get the derivative with respect to V. So you will get a constant and a V square. So this is the relation. So energy, the power is proportional by V3, but the energy is proportional by V square, V cube and V square. So the V square is our accepted answer. Then we go to our next question. So this is the one of the question we also encountered in our last class. So windmills are usually positioned such that the tip of the adjacent windmill touch each other, such that the base of the adjacent will touch each other, such that there is sufficient space between windmills to avoid air turbulence from the windmills affecting the adjacent windmill, and fourth is such that the gears of windmill touch each other. So clearly, the option one will not, option 1, 2, and 4 will not be entertained, because the tip should not be touched. If you have this kind of structure, your tips are close, very close. So the tips will touch each other, and they will clearly provide a lot of friction. So the option 1 is not preferred. Then option 2 is clearly not preferred, because their base cannot touch each other, because the base is the wind, or the sweep area is already higher, much higher than the base. So option 2 is also not correct. Fourth says the windmill gears. So that is also not correct, because gears are inside the, let's say, inside the turbine, or at the center of the axis. So that is also not correct. So it is clear that you should have a sufficient space. So sufficient space is around 8 to 12 d. D means the diameter of the rotor. So this term is important, diameter of the rotor. So the downwind, it should be equal around 8 to 12 d, or approximately 10 d, and here the crosswind spacing should be 4 to 6 d. So crosswind and downwind means this is your direction of wind. So in the direction of wind, there should be 4 to 6 d, and in opposite direction, or in, you can say, the perpendicular direction of wind, it is called the downwind spacing. It should be around 10 d, or the range can be 8 to 12 d, because there is more drag in the downwind side, more drag at the downwind, and so it should be the downwind spacing should be higher than the crosswind. Okay, so this question is again clear, that they should have sufficient speed, sufficient distance between each other to avoid any kind of air turbulence. Then we have the next question. It is on the gearbox of the windmill. So you can see where is the gearbox. So gearbox is somewhere here. So this is the gearbox of the windmill. It is between the rotor shaft. This is your rotor shaft. This is your rotor, and this is your rotor shaft. It is between connecting the rotor shaft to the generator. Because what is, if I ask you what is the purpose of a gearbox, so your rotor speeds are different than your turbine or your generator speeds. So the rotor speed, it can be much higher or much lower than the optimum generating the optimum rotation speed of a generator. So you need to have a optimum speed. So for our AC type of generator, because we need the energy or the electricity with 50 hertz, around 50 hertz. So the rotation speed should be also in that around 50 rotations per second, because in 50 rotations in per second, in 50 rotations, they will be switching their polarity, or let's say their sign of their you can say the uh, this is your AC current. So let's say it is positive, it is negative. So you should have the frequency of 50 hertz. So your rotation speed of your turbine should be, it is written here. So it should also be the around 50 rotations per second. So if you have speeds, rotor speeds larger than that, then you need to convert them to lower speeds by using a gearbox. So what is the mechanism of gearbox? So basically in a gearbox we have two uh, two blades. Let's say this is your A, this is your B. So basically their radiuses are different. So depending upon the ratio of their radius, you will be converting your torque as well as the rotation speeds. So if you need to increase the speed, your A, in that case where your A is having 20 teeth, where your B is having 40 teeth, so your A will rotate twice than your rotation your B. So the gear B will be rotating once. At the same time, gear A will rotate twice, because you need to match the number of teeth. So 20 is equal to 40. So you need to multiply 20 times 2 is equal to 40. So if you are changing the velocities or the rotation speeds, your torque will also change. If your velocity is higher, your torque will be lower for that particular gear. So let's see the question. So gearbox is used in a windmill to typically ensure uniform RPM of the blade and generator, higher RPM at blade, lower RPM in generator, lower RPM in blade, higher RPM in generator, and no RPM in blade but uh, low RPM in the generator, because you need 50 rotations per second, and your rotation of your blade, if you have seen a windmill rotating, you will see you can count the blades easily. So your rotation speeds are quite you can say rotation speeds are quite low. So, and also let's say your rotation speed at blade are around 10, and also you need your rotation speeds at blade lower, because you want to limit their wear and tear, and you don't want to break your blades. So they should be lower. So your rotor we should be lower, but your turbine or your generator we should be higher. So this condition, this is maintained by the gearbox. So that is the use of the gearbox. So the mechanism is simple, as I have told. What we need to maintain the minimum speed of the generator, rotating speed of the generator, and keeping your your rotor or your blade speeds lower. This was the question 6th. Then we have the question on we need to check the statements which are true or not. So the statement A is tip of the ratio. The the tip speed ratio is the ratio of linear speed of the tip of the blade to the wheel. So we have already seen what is TSR. So we saw that the speed at tip versus the speed of uh, wind. So this is the TSR. So we already seen the TSR, which is always less than 1. We need the TSR to be higher as much as possible. So the statement A is correct. The TSR is the ratio of linear speed of the tip. So at the tip and the wind speed. Then the statement B is tip speed ratio is greater than 1 for push design and smaller than so it is always wrong. It is not never greater than 1. So your statement B is not correct. It is not for push design, it is not greater than 1. But for lift design, where your blades are very sharp, it can be more than 1 in this case. But in drag case, it is always less than 1. So always you need to uh, keep in mind that for drag design it is always less than 1, and torque is higher here. For drag design you will get torque much higher than the lift design, and lift design are having speeds higher, so high speed, and this is high torque. Then the statement C is tip speed ratio is smaller than 1 in push design and less greater than 1 in the lift design. So that is correct. This is a, either push or drag. This is the push or drag design, and the middle one is your lift design. So the statement C is correct. Fourth is speed of the blade is more at the center than the tip. So that is not correct, because this is, let's say this is your center. Let me take your pointer. If you
Uh,
can see.
Good evening,
Yes,
sir.
yes, yes,
Sir, may I ask one query
yes, sure.
regarding this? Actually, in this lift design, drag design, and left extreme tip speed ratio, so
Hmm.
lambda is less than 1.
Yes,
There are three
for
categories.
the
We have categorized three.
for the lift design, yes.
So lift
So what
design,
is
lambda
this?
is greater than 1.
Yeah, so it can be happen because of these blades are very sharp. So they
So this means
typical.
in case of vertical horizontal,
Hmm,
lambda may be greater than 1, less than 1 in case of vertical design.
this is a vertical, yes.
Both are vertical, no? Drag and lift design.
Both are vertical, but let me just if give you an example. I can get the 1 minute. I'm not getting the pointer option. Okay, leave it. Mm, Okay, so see, if you are having air something like that, if you are this is your air drag, so you can clearly say that for this drag design your resistance is very high. So if you are having 100% at this side, you will get for let's say only 50%, because the resistance is very high, so most of the power will be converted here. So that since rotation resistance is high, your rotation speeds will be not that high, and your torque will be high but your speeds will be low. And in case of this, let's say you are having 100% initial V1, and your V2 will be also very high, let's say 90%, because the air interaction between air and blades are very low. So your speeds are high, your resistance is low, and your torque is low. So at some point your tip speed over can be higher than the wind speed, but which is not possible in your drag design. So that is the main important. But this is also not a ideal condition. That is why this kind of designs are not very much used. The lift design is not very much used, for small applications like household or small windmills. So for small windmills, mostly a drag design or a semi drag, you can say, optimum drag design is used, where in the horizontal type large scale, let's say this first option, there this lift design is very much used, where the blades are very low, very sharp, so they can achieve a very good speeds. But for drag design, you will not get your lambda is less equal to 1 or near to 1. It will be very less than 1. And for lift design, you can achieve around 1 or slightly higher than 1. But uh, for drag design, it is not possible. So can you repeat what was your exact query? Is it clear or not?
Means two types in case of vertical turbine,
Hmm.
lift design and drag design, right?
Yes, yes.
But in case of horizontal only, in case of horizontal turbine, lambda is always less than 1. But in case of vertical design, as per according to you, there are two conditions: maybe greater than 1 or less than 1, depending on the design, right?
Yes. So for the horizontal type, let's say this your first figure, it is very unconvenient, or the design push design is not possible, because let's see, you have this kind of complete, let's say this for push design, your surface area should be completely covered by your material, by your blades. So if you have, let's say, this kind of structure, you will not get any rotation. And if you want to because here it is spiral in design, you can say, so there is curve. So that is why in horizontal you can get the curves easily. So that is why if your your wind will go in this direction, it can rotate your vertical winds. But for horizontal, it is very inconvenient. So that is why will you see, for horizontal axis you will always get this three blade design. So it is always this kind of lift design. It is never a drag or push design. So that is the main reason of the design of your windmill, because at the end we want the efficiencies to be very high, the highest maximum the maximum efficient possible design. So that is why we don't use the push design in horizontal axis. For vertical type, we can have both designs, but the drag design is more preferred, I would say.
Yes, sir. Thank you, sir. Now understand.
Okay, thank you. So then let's go to our next question. So it is again on our horizontal type windmill. So what is the significance of three blades in a windmill? So we have three statement. In comparison to one blade, three blades are used to increase the interaction with the wind. B is better suitable for generating higher torque, and C is distribution of the load on the shaft is more uniform than the one blade windmill, especially with respect to wind turbulence near tower. So you can clearly see that your option C means distribution of load. So let's say you have only one design, one blade, then your distribution will be at the one blade only. So there is very high torque in a one direction. So let's say this is your, so all the mass is concentrated at at the single blade. So this shaft will undergo a lot of stress while your blade is moving, rotating. And we have also seen that if you have two blade design, so there will be a lot of uh, if you have two blade design, so there is a lot of sweep area available which is unavailable for the blades. So what will happen, there will be very low pressure zone and very high air drag. So your tower will also interfere in this case, where if you have the three blade design, so let's say this is your third wind. So you have minimized area, and uh, before you make any kind of low pressure zone at this your stand or your okay, your stand or your, you can say, your tower. So before you make any kind of low pressure zone, your next blade will approach your tower. So that is why this is not the perfect, not the best. You cannot say it is the 100% ideal condition, but yes, in comparison to others, these three blade design is the best. So it is the most optimum design. That is why we are always using the three blade design. So very rarely see you will see a four blade design or a two blade design. It is similar to your ceiling fans or any kind of your wall fan or any type of fan, because your windmills are similar to fans. So you will see they are always in four, always in three blades. Most of the 99.9% designs are with three blades. So that is the reason your air drag is low, your interaction of tower or the interaction with the stand is low, then your distribution of mass or distribution of torque is even. So overall your three blade design is the best. So this is done. Okay. Then we have the horizontal axis wind turbine again. So you can also see again your horizontal is again drag type or push type, because most of the area is covered here. So this drag design is very much preferred in comparatively preferred more in horizontal type, the vertical type windmills compared in comparison with horizontal type. So the question is, horizontal axis wind turbines access stronger winds? Yes, because you have for horizon for a, yes, for here this is your horizontal edge. So if this is your wind direction, since your interaction is low here, your transfer of torque will also be low. So you can say that the horizontal type can access stronger wind in comparison with the push type or your vertical type, because in that case your torque transferred from air to uh, windmill will be much higher, and your windmill will suffer a lot of pressure on their blades, and they can either break or they can be damaged in that case. Then the second option or the second statement are often mounted on tall towers. So yes, because they need a good height in H type or horizontal type, they need a good wind speed, and that is why they need a good height of the tower. So that is why either they are on tall towers or in places where wind speeds are quite high. So basically the hilly area or the valleys, uh, they are most preferred for the horizontal axis wind turbines, because the air wind flow is very high in in those regions. Then the third statement usually have blades that are pushed by the wind for only part of their rotation. So they are not pushed in that case. That is why this statement is not correct, because it is not the push type. This is the lift type. So in lift type, what happens? You see low pressure zone at one side of the blade. So let us say your blade is rotating in this direction. So you will see a low pressure zone here, and you will see a high pressure zone here. It is due to the design of the wind, design of the blade. So left, your blade will be curved in such a way that when you air pushed, so air will be, let's say this is your wind. So wind speed will be higher in this region, higher wind speed, higher V, and the wind speed will be lower in this region, lower V in this region. So it is all about due to the design of the blade. So where you have the higher velocities of wind, so we know from the Bernoulli's equation or the Bernoulli's relation, your where your fluid speed or your wind speed is high, you will get a low pressure zone, and where your high pressure zone will be where it is relatively lower. So due to this low pressure, you will see a drag force and your blade will rotate. It is similar to what you see in your airplanes. So in airplanes, while lifting off, there's a low pressure zone at the upper side of the wing and the high pressure zone at the lower side of the wing. So the wind will get a drift force uh, upside in case of liftoff and the downside in case of landing. So the same phenomena is used here also. So option 3 is not correct. And option 4 is capture wind energy throughout the rotation. So that is correct, that throughout the rotation, the energy will be stored or converted from wind to electricity, electrical energy. So the option first, option second, option 4 is correct. Only third is not. Then we have the next question. So the question says, where and why is the pitch bearing used in the windmill setup? So need to see the pitch bearing. So the options are blades are attached to hubs and blades are linked using this. It reorients the blade, increase the RPM. So you see where is the pitch bearing. So basically this is your rotor. This whole one is your rotor. This is your turbine and generators and all stuff. And this is your pitch plug. These are your pitch bearing. So what does it do? And your larger images here. So basically they are two bearings attached together. So they allows the rotation or the changing of pitch of the rotor. So it can adjust with the direction of wind or direction as well as the speed of wind. So it can slightly tilt the pitch. Pitch means this kind of rotation. Rotation at on its own axis. So this is your axis of the blade, or this is the axis of the blade. So rotating around this axis, it's called the pitch. It is similar to your screw. So if you rotate the screw or tighten a screw, the axis of rotation is basically the axis of the pitch, and one rotation is the one pitch that is different. But here it is that this pitch bearing is used to blade reorient the blade. So option 3 is correct. The hubs and blades are linked together. So this is your hub, center hub, and these are your blades. So these are linked together with the pitch bearing. Blades are attached to, so blades are attached, correct. And it increases the RPM. So that is not correct because it doesn't increase the RPM. So RPM increasing and decreasing stuff is done in the gearbox bearing. So we have already seen how the RPM is changed. So option 1, 2, and 3 are correct, and option 4 is incorrect. So we'll see the next question. So okay, it is around 8. So we will take a break of 5 minutes or 10 minutes. Then we will be come back for remaining questions. So it is 7:58. So we will meet around.
Sir, I think question number 4 is missing in this.
Question number 4. Okay, question number 4. Okay, I don't have that question. So what is the question? If you can share.
Hello.
Yes.
If the wind velocity is 20 kilometer per hour, then what is the tip velocity? Can be 60 kilometer per hour. It is true or false?
So wind velocity is
Wind velocity 20 kilometer per hour.
Mhm.
Then the tip velocity is 60 kilometer per hour. This is right or wrong?
So you need the TSR values or the lambda value for that. So which kind of windmill? Any specific windmill?
No, sir.
The options are
Only true or false. The question is that if
only
the
true or
wind velocity is 20 kilometer per hour, then the
Mhm.
tip velocity can be 60 kilometer per hour. This is true or false?
Okay. So for that, you need to see what will be your TSR or the lambda. Lambda is your tip speed versus your wind speed. Okay. So tip speed is 60 and your tip wind speed is 20. So you will get around or equal to 3. So you see your 3 is not possible because it will be either less than 1 for most of the cases and will be greater than 1 for very few cases, but still it will not go up to 3. Okay, so your this is false, that your tip speed cannot go up to 60 if your wind speed is
Okay,
20 only. Okay.
thank you.
Okay, so any other question?
सर एक बार क्वेश्चन 1 to 6 रिपीट कर देते सर, थोड़ा लेट ज्वाइन हुआ था मैं.
1 to 6.
जस्ट हाँ
So
जस्ट क्विक
hmm, we can
क्विक रिवीजन
finish
सर.
these we can finish these few more questions, and at the end I can do it. So
जी सर. ओके सर.
okay, okay, so we have few more questions, 5 or 6. So we will just done it them quickly and I will repeat it for you.
ओके थैंक.
Okay. Yes.
Sir,
Yes.
in the lecture, sir has told that the lambda can go up to 10.
Which thing?
The tip speed ratio.
Okay.
In the lecture, sir has told somewhere that lambda can go up to 10.
Up to 10.
Yes.
Okay. So
So just please check from your side if that the
Mhm.
question of
I am not aware of that, but okay, if they are mentioning in the main lectures, it can be. Then this question will be doubtful slightly. But if they mention
just
the specific windmill type, then it is more the question is more well defined, because in this case it is not defined.
true, it's not defined in this case because it is not mentioned it's whether it's lift type or drag type. But even if
Yeah.
considering lift type and going by the lecture may be true, I can
Yeah.
pinpoint where in the lecture sir has indicated. Just give me 2 minutes.
Okay.
I just pinpoint where it is mentioned.
Okay. So if that is the case, so let's say I can just make a note.
Okay.
So your lambda can go up to 10.
Yes.
Up to 10 for lift type.
Or lift type.
Lift type or let's say
It is somewhere around in the where the sir is telling about the tip speed ratio in the slide. There he has mentioned this thing. I'm just
okay, then
reading out.
yes.
I'm just
So that
I'm
is
just reading out
that is
the
fine.
language.
So in that case, this question will be true, and you can correct from my side. Okay. So who has asked the question? I guess Prerna. So this answer will be true, and you can correct, and the tip speeds can go up to 10. So I was not aware of that, but
So
that is,
the wording I am reading just the wordings in the transcript.
yeah.
It is written as lambda could also be greater than 1. It can be, of course, also be equal to 1. So it can be less than 1, greater than 1, etc. So you are looking at a range of values. And usually, I mean, maybe towards the higher end of the spectrum, we are looking at something like lambda could be approximately, say, maybe 6 or 8, or maybe even 10. So that's the statement.
Okay. Okay. So that is fine. So you can correct from my side and just make this question is true. Okay. So the time is 8:05. So let me take a break of 10 minutes. So around 8:14 we will meet and we will just finish these 6 7 questions quickly, and then I will repeat the whatever questions were remaining. Okay. Okay, so let us come back to our discussion. So we are having 6-7 questions more. So we'll quickly go through them. So the question one is, horizontal axis windmill is better than vertical axis windmill because, so basically we need to compare the horizontal one with your vertical one. So we already know. So horizontal is basically this kind of windmill, where your vertical one is, you can say that this kind of windmill. So we know that what are the pros and cons. So let's read the statement. So its blade capture wind energy throughout the rotation. So yes, because let's say this is your sweep area. So they will, for the whole rotation, wherever your blade is, let's say this is rotation, throughout the rotation you will get your uh, wind energy captured, in this case, in case of horizontal type, but it is not true in case of vertical type. So option 1 is correct. So its blade captures the wind energy throughout the rotation. Okay, but not for horizontal type, vertical type. Then it says the second option is vertical axis windmill generates power independent of the wind direction. So that is not correct for the horizontal type, because for the horizontal type you should get your wind direct to be facing directly towards your sweep area. And for vertical type it is correct, because from wherever direction you get your air, your wind, let's say from here, or from any direction, because your axis of rotation is this vertical, so it doesn't depend on the direction of the wind. Although this kind of changes are made in the in the horizontal type, because in many cases, or in most of the cases, your rotation can be changed, or your uh, direction of your turbine, or your direction of your wind facing direction of your blades facing wind, it can be changed, or basically it is on a bearing. So this is your you can say this is your stand, or this is your tower, and you have one bearing here, so which can rotate independently according to the direction of wind. So this design can be used, but theoretically, or without this bearing, it need to be in this the blade direction need to be in the direction of the wind. So the statement second, or the statement 2 is not correct for us. The third option is horizontal axis windmill generates power independent of the wind direction. So vertical. Okay, so third statement is incorrect. This second one is correct, but it is not favorable for us, because due to that our horizontal windmills are not better. So we are not considering this option. Otherwise, your vertical axis windmills generate independent of your wind direction. But it is not true for this particular question. Then the fourth one is, it typically faces less turbulence in the since the mounted higher. So yes, the uh, height is high for this horizontal type, where the vertical types are situated for low height region, or using for small scale applications, and your horizontal type are basically for the large scale applications. Their heights are quite high, the tower lengths are high, so that is why they feel less air turbulence, because as you go higher in the air, uh, away from the surface, the earth surface, the turbulence will be lower. So option fourth is also correct. So we see the accepted answer are the first option and the fourth option. Then we go to our next question. It says the disadvantages of the windmills are, so they create periodic noise. Yes, they can create noise of while rotating. They pollute the air near the windmill. So that is not correct because they do not pollute the air, but they can injure or kill the migratory birds because they can interfere in their path of flying. So that is the accepted answer. And they can cause visual pollution in scenes in sense, so people can negatively impact by the sight of the constant rotating turbines. So yeah, they can visually pollute. So it means if you have, let's say, you are near your home or just behind your home, you have a windmill, and whenever you see from a window, you are always just seeing a rotating blade. So for few people, it can be uncomfortable, delusional, or it can be a kind of visual pollution. So that is correct because not everyone will like that. And if you similarly, if you have a clear field, and in a clear field you have a lot of windmills, so that can also pollute your visual scenarios. So option 1, 3, and 4 are accepted. Then we have the next question. Wind energy is not affected by the solar energy. So again, this question is not very well defined, but we know that your wind energy itself is a form of solar energy. So we, in the last class, we discussed how the wind energy is generated by solar energy. So one, so this is the equator, this is your sun. So you might have seen this kind of diagram in previous class. So due to the rotation of earth, and due to the centrifugal force, and due to the higher temperatures at this region, so your equator will be higher T, temperature will be higher, where at your poles your temperature will be lower. So you will see a temperature gradient delta T between here and there. So there will be a delta T, and due to this delta T there will be a flow of winds, and a large wind current will be generated due to this delta T, and as well as the direction will be according to your uh, rotation of earth. So this is one of the region of wind current, and another region was your surface, or your earth surface will get heated up, so your air will come down, your then the heated air will come upside, so temperature is high here, T1 high and T low here, and again you have a delta T. So due to the difference in densities, your air will move here and there, and you will get a current of uh, air, or which can, you can say, the wind currents. So basically, your wind energy itself is a product of solar energy. So the statement is false, that we cannot say these are not affected by each other, or the wind energy is not affected by the solar. Then the fourth question is, we have the statement. So this statement is the minimum distance between two windmills. So we saw that if you have one mill here, one windmill here, and let's say your one is here. So your let me see, show you that. Okay. So downwind and crosswind. So your downwind should be around 10 D, and your crosswind should be, if this is your downwinds, it should be around 10D, and this is your crosswind. This should be around 5D. So D is what? D is basically your diameter of this. This is your D. So you should have sufficient distance, horizontal distance and vertical distance. So if you have, let's say 50 D is your 50 meters, so your downwind should be 500 meters and your crosswind distance should be 250 meters. So this is a typical condition or the minimum distance between the subsequent windmills. So we need to see the conclusion which are correct and which are not. Both two windmills which are installed at the distance of 500 meter apart are not generating same quantity of power. Possible reasons are, so we are just being asked about two windmills. So first option is both windmills might not having getting the same quality of wind energy. So if they are not in the 500-meter range, or their distance is not kept of 500, then their air quality or the wind quality will not be same, because one will generate a drag. So let's say this one is generating the drag, so the air or the wind will be affected by this drag and your efficiency will lose for this second windmill. So the option 1 is correct. Both windmills having same different blade size. So that is also option, because if you are having same 50-meter blade size and you are not keeping 500-meter, or you are not generating the same quality, so that can be one of the reason. One of the windmill might be a vertical type and with another will be horizontal type. So this is because this minimum distance criteria is for the same type of windmills. So if you have one is another one is horizontal type, or one is horizontal type and another one is vertical type, then this rule need to be modified, because the air direction or the wind direction required will be different for both. So the third option is also considered. The fourth one is windmills that are 500-meter apart can never generate the same amount of power. So, but they are, if they are 500-meter apart, they can generate equal power, whatever their efficient power is. So the option 4 is not correct. So option 1, 2, and 3, they are considered. Then we have the fifth question. So it is again this simple question: the direct type blade and the lift type blade. So we know for the direct type, your velocities are low, and for your lift type, the velocity or tip velocities are high. So direct type will be smaller rotation speed, and lift type will be higher rotation speeds. Then is typically used for generating this electricity, is typically used for pulling. So B is typically used for generating electricity, because we know the rotation speeds are high. So our criteria for 50 hertz are easily matched for this kind of for lift type. So for lift type, 50 hertz criteria or rotation of 50 rotation per second can be easily achieved. But the drag types are used because their velocities are low, so their torques are high. So this condition can be used because we have high torque, means high force. So high force means you can pull water, or you can do heavy whatever heavy works you need to, let's say, moving one heavy mass from here to there, or just grinding or pulling water, whatever the high torque activities are, you can easily do with the direct type of blades. So this is a basic comparison versus for velocities and torques and their different applications for deck type blade and lift type blade. Then the sixth question is windmill energy generation depends on what? So volume of the air going through, yeah, that is correct because volume is important in that case. Q power of the wind speed. So we saw that wind speed depends on the v to the power 3. So that is correct. Height of the windmill. So yes. So if your h is high, so that is preferred. So your volume, your cube of your velocity, height, as well as presence of transition infrastructure in the city, transmission infrastructure in the city. So transmission is just from the windmill to your city. So these are, let's say, your transmission lines, which are your transmitting your power, generated power from windmill to your city. So this is not considered, or your windmill energy generation will not be depending on the infrastructure of transmission. So that is not correct. So only option 1, 2, and 3 are correct. Then we have the last question. Okay, I guess the question is from the previous discussion of the sacrificial agent. So we just talk about that. So what is the sacrificial agent in the particle side reduction? What will be affected? Okay, let me read the question. Sacrificial agents in particle size reduction reduce the band gap. They cannot. Electron hole plane recombination they do, and the probability of generation or the gap between the valence and conduction band, it is not the correct. So only the electron hole recombination they can reduce. So this is from the last to last class. Okay, so I guess these 7 questions are done. So I will just repeat the questions which were required from 1 to 6, right? Or 1 to 4. Okay. So who has the issues in the questions?
सर क्वेश्चन नंबर 1 to 5 once again repeat कर दीजिएगा.
2, 5, 1 to 5. Okay, okay. Let me check. So I'm just repeating. If anybody has not marked your attendance, please mark your attendance. So 1 to 6, these are from this question.
No sir, main assignment question.
Main assignment question. Okay, this question.
After this sir, after this.
After this, so the second one.
Yeah.
So this is basically
From
the
first one.
best from first, from here.
Yes sir. Yes,
Okay.
from first. This is second question.
So from this first, right? Okay, slides is still showing this second.
Yes sir.
Okay. So this question is from the relation of power from a windmill. So I'm not deriving the derivation, or I'm not deriving the relation. So it is derived in the main lectures or in main notes, I guess. But I'm not going to derive it. I'm just showing the relation. So wind power is basically either v to the power 3, means the velocity power 3, or v multiply by v1 square minus v2 square. So what is v1? V1 is the velocities before hitting the windmill, and the v2 is the velocity after hitting the windmill. So the difference of the velocity shows the power transferred to the windmill. So if you have the higher the difference, that's a 100 to 50% loss in the velocities, means your power generated is higher. And if you have smaller, let's say 10% only, then your power is generation is lower than that case. So wind power is proportional to difference of V1 square minus V2 square, the difference, the area, sweep area, that is clear, this is your sweep area, then velocity, and then rho is your constant for the fluid. So for air it is fixed. So these are the relation. So option 3 is correct, and this relation is correct in that case. Then we have the question on Bates limit. So Bates limit we have already discussed. Bates limit is the maximum theoretical efficiency for a wind turbine. So option experimental is not correct. It is theoretical as well as it is 559.3%. So more than the 59.3% is not possible for any windmill, and typically these are around 35 to 45% because a lot of components are there. Then a lot of friction between different components in gearbox, in turbines. So a lot of losses are there. So it is typically the 35 to 45% efficiency you will achieve. Then the question was the velocity. If v is the velocity of the wind, energy available of wind is proportional to what? So we know that power is given with this formula v to the power cube, or v to the power 3, or v cube. So this is the velocity basically. So they are asking, not asking the velocity power, they are asking about the energies. So we know the relation from energy to power, or from power to energy. So for E we need to differentiate the or take the derivative of P with respect to whatever coordinates you have. Let's say here you have V, so dP by dV. So what it will give? It will give you a 3V square. So 3 is basically a constant, so you will get a V square. So your energy produced or energy available is proportional to V square, where your power produces proportional to V cube. So you need to take care of that energy, or they are asking about the energy, or they are asking about the power. Then this question is from the distance or the positioning of different windmills. So if this is your windmill direction, let's say from here we are getting the wind direction. So in direction to the wind, this is called your crosswind spacing, and the perpendicular one, this is called your downwind spacing. So basically your downwind spacing should be 10D, around 10D, or it can be in the range of 8 to 12D. D is your diameter, so this is your D, and your crosswind should be 4 to 6D, or around 5D. So this is a typical range, depends on the different conditions. So because you will, if you have, let's say this is your center windmill, so while rotating it will produce some turbulence. So let's say this turbulence. Similarly, if you are having this windmill rotating, you will get this turbulence. So if you are putting your another windmill close to it, the turbulence will affect the wind quality and the efficiencies will go down. And if you have lot of space between them, then your space will be not optimized, will be utilized properly. So you will lose your space. So that is why this 8 to 12D, this is your optimum distance. So you are not losing your empty space, as well as you are not losing your efficiency. So this is the most optimum condition. Then this question is on the gearbox. So the gearbox is used in what? So we know what is the gearbox. Basically, we have two gears, A and B. Their radiuses or the diameters are different depending on the difference in in their diameters. Their rotation speed will be changed. So let's say you have 20 teeth in your A gear and 40 teeth in your B gear. So your gear ratio is 2 to 1. So when your B gear will move or rotate with one rotation, your A gear will rotate in two rotations. So this is the condition. This is the example. 20 times 2 is equal to 40. So what will happen? So what we can do here, because your rotor speeds are lower than your turbine speeds, because for turbine you need at least 50 hertz, 50 rotation per second, because you need a AC power of 50 hertz. So 50 hertz means your polarity will change 50 times in a second. So in that case, you need 50 rotations per second to get a 50 hertz power, a 50 hertz signal, or let's say 50 hertz AC power. So in that case, if your rotations are not 50 times per second, or if they are higher or if they are lower, you need to maintain it to 50. So that is why they are used, the gearbox are used in between your rotor shaft and your generator. So let's say your rotor shafts are, your rotor is rotating with 10 rotation per second. So your gear with rotation of with the gear ratio of 5 to 1 can be used to apply to make the velocity, rotation velocities 5 times higher than the rotor. So you will get the 50 rotation per second or the 50 hertz. So this is the application of, so option 3 is correct here, and this is the application of gearbox. So I guess these are covered. So we have done most of the questions, or the all of the questions for today, and this was our week 8. So we have 3 more weeks left, 9, 10 and 11, 4 more, 9, 10, 11, 12. So if you have any kind of doubts, any queries, so you may ask, and I am happy to answer all of them. And if not, our discussion is, the content of the discussion is done for today. So if you don't have any doubts or any queries, you may leave at your will. And before leaving, please ensure you have written your name in the chat box. Otherwise, you can ask whatever doubts and query you have. I am here till 9. So if you have any doubts, any questions, you may ask. Yes, sure. Thank you for attending.
Question number 10, option will be A, B, and C, sir. Question 10. Last
This
question.
one, of the
10th number.
pitch bearing, right? For the pitch bearing question?
Okay, sir. ABC.
Yeah. So option 1, 2, and 3 are correct, because it will not increase the RPM. Only they will allow to rotate over rotate over the axis of the pitch, or the axis of the blade, you can say.
Okay, question number 9.
9.
Yes.
This one.
Yes. Horizontal axis.
So here the option 1, 2, and 4 are correct. So option 3 is not correct, because
Yes.
it says usually have blades that are pushed by the wind, but in the horizontal case it is not pushed, they are rotated.
Sir, we have already discussed earlier. That means the wind velocity is 20 km per hour and the tip velocity can be 60. So what will be the
Yes.
correct answer, sir?
So as we corrected them, so in the lecture the professor has said that it can be up to 10, lambda can be go up to 10. So in that case, the option is true, that lambda of 3 is possible. So we can say that, yeah, so it will be true.
It's true. No. Okay, sir. Thank you. Thank you, sir.
Okay, so thank you for attending this session. So I will be concluding the session and ending the meeting. So we will meet next week for our week 9 discussion at the same time on Tuesday at 9 p.m. Thank you all.